Okay, in this first video, we are going to talk about the normal distribution and z-scores. So, we'll start with an example here. Let's say I'm told that the height of adult males is normally distributed with a mean of 69 inches and a standard deviation of 7 inches. Okay, first of all, it's important to realize when we're talking about the normal distribution, and I'm talking about the height of adult males, I'm not talking about a sample of adult males. It's not like I picked out a random sample of 50 adult males. I'm saying that all adult males are normally distributed with a mean of 69 inches and a standard deviation of 7 inches. So I'm talking about the entire population of adult males. And there's some notation here that we haven't introduced yet. And it would be the following. Okay. This is a Greek letter. These are both Greek letters. This is mu. Okay. Mu. And it's a lowercase m in the Greek alphabet. And it stands for the mean. So the population mean is 69 inches. And then this is sigma. It's a lowercase m in the Greek alphabet. And it stands for the population standard deviation. Okay? So if it were a sample, it would be x bar. This would be x bar and that would be s. But since we're dealing with the population, this is mu and that's sigma. And they come from the Greek alphabet. So to say that the height of adult males are normally distributed, what we're saying is that they have a bell shape to them. Okay? So this would be like the shape of the histogram. So the idea is if this were like the frequency, then you would have bars here like this. And the actual shape for the distribution would have this kind of this bell shape to it. Okay, it would be somewhat symmetric. It would be symmetrical. The majority of the data would be there in the middle. Okay, and it would have that normal shape to it. This is very common in statistics. Okay, so these would be like the heights here. This would be like the number of adult males that are that height. Okay, and the mean here is going to be in the center of the distribution. 69 inches. Okay, the standard deviation I'll write right underneath it, 7 inches. Okay, and so one thing that's true about a normal distribution is pretty much all of the data is within 3 standard deviations of the mean. And so what I can do is I can kind of put, there's 1, 2, 3 standard deviations below, 1, 2, 3 standard deviations above. Okay, and pretty much all of the data is going to be within 3 standard deviations of the mean. So you can actually write out what these heights would be. 69 plus 7 would be 76 inches. And then 76 plus 7 would be 83 inches. And then 83 plus 7 would be 90 inches. 90 inches. Okay. And then if I subtract 7, 69 minus 7, that would make this 62. And then 62 minus 7, this would be 55. And then 55 minus 7 would be 48 inches. And this is actually, 90 inches is actually like 7.5 feet tall. 48 inches is actually 4 feet tall. And that would be about right. I would say the majority of adult males would be between 4 feet tall and 7.5 feet tall. Okay, so this actually fits what we know about the height of adult males. Now, the normal distribution, it actually has a certain shape to it, and for all things that are normally distributed, the percentage of data that lies within 1, 2, and 3 standard deviation is going to be the same for all normal distributions. And actually, the percentage of data that lies within 1 standard deviation on either side of the mean will always be 68% of the data. And that 68% is a little more than 2/3. So within 1 standard deviation of the data, you have the middle 2/3 of all of the data. Okay, so a lot of the data is right there in the middle. Now within 2 standard deviations from the mean, you actually have 95% of the data. And so right there, that's pretty much all of the data is within 2 standard deviations. Only 5% of the data lies outside of that. So what about 3 standard deviations from the mean? So within 3 standard deviations, you actually have 99.7% of all of the data within 3 standard deviations from the mean. So you really have pretty much all of the data within 3 standard deviations. Okay, 99.7%. So that means only 0.3 of 1% lie outside of that. So only 0.3 of 1% would be less than 4 feet or more than 7.5 feet. And 0.3 of 1%, that'd be like 3 out of 1,000. You'd have to pick 1,000 people before you find someone that's that short or that tall. So that actually makes pretty good sense. Okay, so that's like the normal distribution. So different normal distributions will have a different mean and standard deviation, but you can lay out 1, 2, 3 standard deviations on either side of the mean, and these percentages will always hold. If you're wondering where these percentages came from, they actually come from a normal table, and we're actually going to show you that normal table in another video. Okay, but it's mathematical. There's an actual curve that represents that normal curve, and those percentages hold for all normal curves. Okay, now let me talk about this idea of z-score. So these values here, the actual heights, we think of those as being like x-scores. Okay, these are the actual values. Now corresponding to each one of these is a z-score. So a z-score of 0 is the mean. The mean is in the center, and so that's a z-score of 0. So 1 standard deviation above is a z-score of 1. 2 standard deviations above is a z-score of 2. 3 standard deviations above is a z-score of 3. And so 1 standard deviation below is -1. 2 standard deviations below is -2. And 3 standard deviations below is -3. So these are the z-scores. Okay, and the z-scores are like numbers between -3 and 3. They could lie outside of that, but by the time you get to -3 and 3, you pretty much have all of the data. Okay, these are the whole number z-scores. Now you can have z-scores that that lie between these. So like, let's say 57. Let's say I'm interested in the height of someone who's 57 inches. Okay, let's say that's our x. X equals 57. Okay, so the question is, what would the z-score be for that? What is the z-score for 57? Okay, somewhere between -1 and -2. Well, there's a formula for that. Okay, there is a formula. And so the formula is this. We can call this the z-score formula. And the z-score formula is the following. Z is equal to the x score. This is the x that you want to convert to a z-score, minus the mean divided by the standard deviation. Okay, so for our example here, the mean was 69, the standard deviation was 7, and the x is 57. So the x is the one that I want to convert into a z-score. Okay. So plugging this into this formula, this is 57. That's the one I'm going to convert to the z-score. Minus 69 divided by 7 divided by the standard deviation. Okay, and then let me get my calculator up here. When you do this, it's very important that you put it in your calculator right. If I do this, 57 minus 69 divided by 7, if I do it like that, I'm not going to get the right answer, because this is going to take 69 and divide it by 7 first before it does the subtraction. And here you want it to do the subtraction first. So there's two ways you can do it. You can do 57 minus 69 in parentheses and then divide that by 7. And there you get the z-score, negative 1.71. Okay, and you're always going to round these to 2 decimal places. And the reason is when we look them up on the table in the next video, z-scores will be to 2 decimal places. So round to 2 decimal places. Okay, the other way you could have done it in your calculator is you could take 57 minus 69, hit return, and then divide that by 7. Divide the answer by 7, and then there you would get the answer as well. Okay, so let's try another one. Let's say I want the z-score for, we'll use the same mean of 69, standard deviation of 7, and let's say I want a z-score for x equals 85 inches. Okay, so 85 inches is like right up here somewhere. So it's between a positive 2 and a positive 3. Okay, so using my z-score formula, I would do 85 minus 69 divided by 7. So using my calculator, 85 minus 69, return, divide that by 7. And I get 2.29. I'm going to round to 2 decimal places. 2.29. And that would be the z-score. Notice that whenever you use this formula, it's always the x minus the mean. X minus the mean. Even if the x is less than the mean. Because you actually want a negative z-score. If x here lies below the mean, you want this z-score to be negative. And that's why it's negative. Okay, if it's above the mean, the z-score will be positive. So it's always the x minus the mean divided by the standard deviation. And that will give you the z-score. So for any height along here, it'll tell you where amongst the z-scores. It'll tell you the z-score for that height. So that is the introduction to the normal distribution and z-scores. In the next video, we will show you how to use the standard normal table.